Hello and welcome to this video. So as we have completed complex numbers and problems on complex numbers, we will move on to polynomials and quadratic equations. That is, we will study the theory of polynomials and theory of equations. I will go slow and introduce the theory in several videos because there is a lot of theory in this. So if you are new to the channel, make sure that you subscribe to the channel and press the bell icon so that you can get notified about more upcoming videos on mathematics of class 12 or other classes. Once I finish class 12, I will make class 10 videos. So with that aside, let's get into this video and let's see what we have here. So the chapter is polynomials and theory of equations. So what is a polynomial? A polynomial is of the form n x to the power n plus, there should be a plus, n minus 1 x to the power n minus 1 plus so on up to a1 x plus a0, where ai belongs to the set of complex numbers and I varies from 0 to n, that is I greater than equal to 0, and I belongs to the set of integers. Now since ai belongs to complex set of complex numbers, clearly A belongs to set of real numbers because set of real numbers is subset of set of complex numbers. So this equation, this polynomial equation, is called an equation of degree n if and only if n is not equal to 0. N is called the leading coefficient of the polynomial. If the leading coefficient is 1, then the polynomial is also called monic polynomial. So these are definitions we are going through. A polynomial with one term is called monomial, with two terms a binomial, and with three terms it is called a trinomial. The most useful trinomials are quadratic equations, as we will see, which we will study further in this chapter. If fx is equal to a0, that is all these terms are 0, then it is called a constant polynomial. If n is equal to 0, it implies fx is equal to a0, which will be a polynomial of degree 0. If fx is equal to 0, then it is called a zero polynomial. In this case, the degree is defined as minus infinity to satisfy the first two properties given below. We take domain and range of these polynomials or functions as set of complex numbers C, a real number R or a complex number Z for which fr is equal to 0 or fz is equal to 0, then R and Z are called zeros, roots or solutions of polynomial. So what are the properties which I talked about? If fx is a polynomial of degree p and gx is a polynomial of degree q, then fx plus minus g of x is a polynomial of the degree max of pq. So if you add or subtract, then the maximum of p or q will be taken. Fx into gx is a polynomial of degree p plus q, and f of g of x is a polynomial of degree p dot q, p into q. This is multiplication, where gx is not a constant polynomial. The fx shown, so the first two properties were these two. To satisfy this, the zero polynomial degree is treated as minus infinity. The fx shown at the beginning is a polynomial in one variable, and similarly we can have polynomials in 2, 3 or so on m variables. The domain of such a polynomial of n variables is set of order m tuple of complex numbers, and range is set of complex numbers. Let me hit full screen. Forgot to do that. Now, division of polynomials. If px and dx are any two polynomials such that dx is not equal to 0 or not equivalent to 0, then two polynomials qx and rx can be found such that px is equal to dx into qx plus rx. So here d you can think as in divisor, q as in quotient, and r as remainder. Here the degree of Rx would be less than the degree of dx or Rx equivalent to 0. Like numbers, Qx denotes the quotient and is called so, while Rx is called the remainder. Particularly if Px is a polynomial with complex coefficient and z is a complex number, then a polynomial qx of degree 1 less than px will exist such that px is equal to x minus z into qx plus r, where r is a complex number. Now we go through some theorems which will be useful in solving the problems. So first of them is the remainder theorem. Remainder theorem states that if fx, a polynomial, is divided by x minus alpha, then the remainder is f alpha. So we write fx as x minus alpha into qx plus r. So our quotient is qx, divisor is x minus alpha, and remainder is r. Now f of alpha, we substitute x is equal to alpha. So this will become 0, making this entire thing 0, and remainder would be equal to f alpha. So that is the remainder theorem, and the proof is there. Next theorem is factor theorem. Factor theorem states that fx has a factor x minus alpha if and only if f alpha is equal to 0. Now from the remainder theorem, if we follow, we are given that r is equal to f of alpha is equal to 0. Okay. Now if f of alpha is 0, then f of alpha is equal to x minus alpha into q of x. So clearly fx has a factor of x minus alpha. Next one is fundamental theorem of algebra. This L should be small. This is concerned with the roots of the equations of a polynomial. Every polynomial of degree greater or equal than 1 has at least one root / solution / 0 in the complex numbers. We can also say that fx introduced in the beginning with n greater than equal to 1, then there exists a z in complex set of complex numbers such that f of z is equal to an z to the power n minus 1 plus az, this should be an minus 1 z to the power n minus 1, this is a typing mistake, and so on, plus a1z plus a0 is equal to 0. Now it is trivial to deduce that an nth degree polynomial will have exactly n roots of x is equal to a into x minus alpha 1 into x minus alpha 2 and so on up to x minus alpha n minus 1 into x minus alpha n. Some notes are there on the roots of the polynomial, that is, some of the polynomials may have repetition. For example, you consider the polynomial x minus 1 whole to the power 3 or 4 or 5, then 1 is repeated 3, 4 or 5 times. If a root alpha repeats m times, then m is called multiplicity of the root alpha, or alpha is called m-fold root. Quadratic surds of the form square root of a plus square root of b, where square root of a and square root of b are irrational numbers, then it will have its conjugate as a root. Similarly, if a complex root occurs, then it will always occur in pair with the complex conjugate as another root of the polynomial. However, if the coefficients are complex numbers, then it is not mandatory for complex roots to appear in conjugate pairs. So you can remember that irrational roots will appear in conjugate pairs, and complex number will also appear with the complex numbers and its conjugate pair. But the coefficients, if they are complex numbers, then it is not mandatory. Next we have identity theorem. If fx, a polynomial of degree n, vanishes for at least n plus 1 distinct values of x, then it is identically 0. So we have f of x is equal to a into x minus alpha 1 into x minus alpha 2 up to, this should be x minus alpha n minus 1 into x minus alpha n, and we let that it vanishes for alpha n plus 1, then f of alpha n plus 1, this x should be alpha n plus 1, is equal to a into alpha n plus 1 minus alpha 1 into alpha n plus 1 minus alpha 2, and so on up to alpha n plus 1 minus alpha n minus 1 into alpha n plus 1 minus alpha n is equal to 0. But because alpha n plus 1 is different from alpha 1, alpha 2, alpha n minus 1, alpha n, none of the terms will vanish, which implies that a will be equal to 0, that is fx is equal to 0. So this is the identity theorem proof. Now there is a corollary related to this. Consider two polynomials fx and gx having degrees p and q respectively such that p less than equal to q. If both of them have equal value for q plus 1 distinct values of x, then they must be equal. The proof is let hx is equal to fx minus gx. This implies that the degree of hx is at most q and it vanishes for q plus 1 distinct values of x, which implies that hx is equal to fx minus gx is equal to 0. So fx is equal to gx. So that's the corollary. And with this we come to the end of this video. In the next video I will introduce more theorems and more topics related to polynomials and theory of equations, and it will take 4 or 5 videos to completely cover this theory part of this topic. So I hope you have found this video useful and informative. Please like the video and share it on social media as much as you can. And don't forget to make use of the comment box to make suggestions or improvements, or if you want certain topics to be discussed, then let me know and I'll try to see what I can do. Thanks a lot for watching. Have a nice day.